Asteroids are witnesses to the past of our solar system. NASA finds asteroid and then finds something completely unexpected. Asteroids are mysterious objects that are witnesses to the origin of life, but they can also destroy our civilization in seconds. So what would happen if one of these celestial bodies collides with Earth? Could we really defend ourselves? Or are our governments trying to lull us into a false sense of security to protect us from the unimaginable? DART mission was launched by NASA. Mankind succeeded for the first time, pushing an asteroid off course. It's a great success for NASA. We changed the course of an asteroid so we can save our species in an emergency. But if an asteroid maybe a few kilometers wide hit the Earth, then a huge amount of the Earth would have been devastated in a very short time indeed. Whatever preceded this, the rest of the planet would be changed completely, beyond its capacity. To accept change, as this would cause consequential damage and open the Earth's crust. But in the days and weeks ahead, we might be history. Not quite a week later, that's what happened 60 million years ago when the Chicxulub asteroid hit. They disappeared from the Earth forever. It doesn't matter if you're just a human. Humanity has to do something or else it's going to be wiped out one day. Just like the dinosaurs, really. Having dinosaurs wiped out was like an evolutionary step back, and it makes no sense to go backwards. The next big asteroid is coming. That's clear, and in the face of this cruel certainty, we must all do what we are required to do and use our technological capabilities to make an active asteroid defense. A dozen or so international space agencies and nations have already sent probes to asteroids and comets. The Japanese Hayabusa mission groundbreaking samples and information from the asteroid Itokawa between 2003 and 2010. One of the most dangerous asteroids to date, Bennu is the target of NASA's OSIRIS-REx mission, which sampled the asteroid in 2016 and is on its way now to Apophis. ESA is also keenly interested in asteroid and comet research. Even more, the Rosetta probe did reach the comet 67P Churyumov-Gerasimenko and indeed did deploy a lander. The mission highlight thus far was DART, and the probe just slammed directly into the surface of the asteroid Dimorphos and pushed it out of its orbit. DART, the asteroid defense pioneer. It sounds like a sci-fi scenario. An enormous probe on an unswerving course to an asteroid in order to alter the course of mankind. NASA's Double Asteroid Redirection Test project, known as DART, did that. This probe may seem a bit over the top, but it just might save our lives. The threat is not immediate, though it could creep up on us before we know. When an asteroid shows up on our doorstep, we get a few hours. One day, DART's successors could save our lives. One of the cornerstones of our asteroid defense, the lessons learned of this mission's scientific precision and technological innovation, are already history. So, why is this mission so important? And what unexpected insights did the collision with Dimorphos teach us? But DART tells us in a frightening way just how close the line between threat and protection can be. There was no way to miss the double asteroid redirection test. The probe was made to be destroyed, but it was expensive. Dimorphos, an asteroid, was the target, and DART wasn't designed to return. The mission was launched on November 24, 2021. At 1 from Space Launch Complex 4 of the Vandenberg Space Force Base in California, the rocket would lift off 20 a.m. local time. The mission type was planetary protection by a kinetic impact. Author: what this meant, in recap, was that the DART probe was to make a direct impact on the asteroid's moon Dimorphos in the Didymos system in a way that would cause it to be pushed out of orbit. This would be good defense in an emergency. There is simply only one method, and that is one that is deemed the most effective by experts, because only a kinetic impact can change the course of an asteroid by just so much, with so much precision and control, without exacerbating the risks. In stark contrast, detonating an asteroid would be more problematic than problematic. 1,000,000 times more powerful than the Hiroshima bombing, This explosion would break the aged asteroid into many very dangerous pieces that would hurtle untethered towards Earth, 1,000,000 times, 10 million times more violently. In the case of an emergency, an alternative is to tow asteroids with probes. In the approach presented here, the asteroid would be pulled progressively out of the collision path by a series of one or more space probes that slowly dock with the asteroid and provide a continuous thrust to put it on a different trajectory. However, this method, while theoretically effective, would be prohibitively representative and also would require extremely precise calculations and long-term planning to be truly successful. It is certain, however, that if we do reach this point, we will need to change the course of potentially dangerous objects in order to keep them from hitting the Earth. The good news is that this could be achieved with only a few meters of instructional video. The sooner we find the asteroid or comet, the easier it would be to nudge its orbit until it can no longer hit us. To come straight to the point, that hope is there. The first time an asteroid's orbit was changed by a kinetic hit, so we are safe from a real one. Impact successful. A dust and debris column 100 meters high. At NASA, where that dart struck Dimorphos moving at 6.6 kilometers per second, it was as quiet as a mouse. They connected experts and governments all around the world as witnesses. Nobody knew, at first, whether the impact had really done what it was supposed to do. The view was obscured by a 100 meters high cloud of debris, until shortly before which DART's camera was filmed, and when they were impacted at which the image was interrupted, as this was recorded. After all, the Laia Cube probe launched in 2022 was going to this unique event traveling on the spacecraft. The probe was contributed by the Italian Space Agency to document the impact. DART filmed the entire impact from a safe distance, even though the probe had already been smashed to 1,000 pieces. The 100-millimeter high cloud of dust and debris is shown in some of the images. At the speed of around 22,000 km/h, the impact swirled up so much material at first that the whole asteroid became invisible. However, for some time, tension in the NASA Control Center remained high. We knew that DART hit the asteroid, yet the importance of a probe picking up where it was pointed should not be underestimated, even if it hits its target to several meters. In the case of active asteroid defense, the first data obtained Laia Cube and the many telescopes which watched the impact from Earth came in on fire. Extensive analysis later confirmed that the kinetic impact altered Dimorphos' orbit to a much greater extent than had been planned. Exactly 1 hour and 15 seconds was taken off the asteroid moon's orbital period. This mission was a complete success and is the basis for our planetary protection strategy. The data from the Italian probe even today gives scientists valuable insights into the dynamics and effects of impacts of this size. To make the most of the mission, another probe is due to visit Dimorphos and its parent asteroid Didymos in the fall of 2026. The ESA is organizing this mission and will return detailed information about the internal structure of the asteroids. The impact site will be examined in detail, and the details of kinetic tracks and chemical changes on the asteroid will be documented. Just how much time would we have in an emergency? Isn't it scary that the last 10 years have seen 2 asteroids pop up out of nowhere and cause damage that couldn't have been predicted? Small asteroids are tricky because they are small. Their estimated diameters are just a few meters, and range only limits the best telescopes to detecting many of them. One asteroid of this sort exploded over the Russian city of Chelyabinsk, shattering thousands of windows with a shock wave. At the unusual noise, hundreds of people rushed to the window and got trapped. Many houses were damaged and they suffered lacerations. But this asteroid was only a few meters in size and caused extreme damage. Might you not imagine what an asteroid the size of a detached house or a football stadium might do? The Chicxulub asteroid that destroyed the dinosaurs 66 million years ago probably had a diameter of about 15 kilometers. Such a hunk of rock hurtling through the Earth's atmosphere and landing with a thunderclap in the Earth's crust is apocalyptic. The Chicxulub comet hit the water a little bit and slowed it down a bit. But the combination of the impact caused a tremendous ripple that went circling the world. But the amount of time we have in the event of an asteroid impact hinges completely on the size, speed, and distance of the celestial body. If an asteroid's orbit is known, larger asteroids can be seen years or decades ahead of impact, but it remains sobering. Only about 40% of near-Earth objects with diameters greater than 140 meters are currently catalogued, according to experts. Gravitational slings within the solar system can pull these objects out of their known orbits as they enter Earth's atmosphere at any time. The object Oumuamua also was an alarming warning. The around 1 kilometer-wide object has yet to be more clearly identified but only passed the Earth at close distance. The real reason Oumuamua was so treacherous was that it didn't absorb any light. It could have hit the Earth. In cosmic terms, the transit distance, roughly 24 million kilometers, is ridiculously small. What if we found an object this size a couple of hours or even days before impact? The little time we would have left would be short enough to become disaster. Can Apophis destroy us? Anybody who has ever named an asteroid after the Egyptian god of chaos and destruction should know what he's dealing with. On June 19, 2004, an observatory in Arizona first spotted the asteroid that would eventually receive the official moniker 99942 Apophis, and thereafter became the object of science and public fascination. Different times since then have seen confusion and discussions of Apophis. Is this next asteroid going to hit the Earth? When it was discovered in 2004, astronomers figured Apophis had a 1 in 37 chance of the two bodies colliding on the next flyby, on April 13, 2029. This number was troubling the world. About 340 meters wide and 27 million tons in mass, Apophis has a diameter of about 340 meters. If it had collided, it would have released a 12,200 megaton TNT energy. To do that would be enough to blast a whole continent into outer space and do terrible harm to the Earth. The orbit calculations were improved with further observations, and it was initially considered that an impact in 2029 would be unlikely. But we realized Apophis 2029 will come unusually close to Earth. That's going to get down to something of around 31,000 kilometers. So close, in fact, that it will pass closer to us than some of the satellites we send up. If Apophis comes through this deflection zone of 600 meters, the Apophis could change the orbit so a collision occurs 7 years later. In 2021, NASA published another set of calculations, and after that, the final probability of an impact in the next 100 years was finally ruled out. Apophis is taken off the warning list, but the asteroid is to remain under observation. We already have one on its way to Apophis. The OSIRIS-APEX mission intends to bring rock samples of Apophis back to Earth in a few years, so that we'll be ready if an emergency arises. This will allow us to design a DART-type probe, which can push the asteroid out of a collision path before it is too late. Several space agencies will launch missions in 2029 to learn as much as possible about the asteroid Apophis during its flyby. Don't miss any new videos.